And of course, that gives you 80.5 centimeters and 81.5. Now, be careful. Use the inequality symbols. This symbol means that it can include 80.5, and this symbol here means that it can't. It can go up to that, but can't use that number properly. Okay. Right then, solve x squared equals 3x plus 18. Now, most people would look at that and go, "Oh no, how do I solve that? How do I solve that?" Because you don't see this shape usually. The usual shape for this type of solution is this one. Right? It's a quadratic. I know it's a quadratic because of that x squared. So if you're not confident with that shape, then convert it into that shape. Make sure that you do have something x squared plus bx plus c is equal to 0. And how you do that is, of course, you do the inverse. So it becomes x squared. The inverse of 3x is negative 3x, or take away 3x. And the inverse of adding 18 is subtracting 18. And since there's nothing on the right-hand side now, it's equal to 0. And you've got it to that same shape. And now you can use your own strategies, whether it's using completing the square, whether it's using the formula. For this one, I have to be honest, the best way is to factorize, because 3 and 18 implies to me 6 and 3 in some combination. And as it happens, it's negative 6 and 3. So x could be 6 and x could be negative 3. Right. Hopefully that gives you some ideas on these types of questions. Right. At certain points in this YouTube live, remember, it's called YouTube Live, but you can pause it and you can rewind. Be kind, rewind. Okay. So if you're struggling with something, or I went too fast for you, rewind a bit. Right. You're not going to miss anything out. Right. We'll still be here. So rewind. And in this section here, just pause it for a second. Second. If I can get my false teeth back in. Right. Pause it for a second. Have a go at it. Right. In a sale, the normal price of a TV is reduced by 5%. The sale price of the TV is £452. Work out the normal price of the TV. Is it A? Is it B? Is it C? Or is it D? I'm going to go through the answer with you now. Right then. The answer is B. Now, the sale price of the TV is £452. That's implying to me that you've already done the calculation and you've got the new price. What this is asking you is what the original price was. So it has to be reverse percentage. Okay. Reduced by 5%. So you know you've used a multiplier of 0.95. So you've multiplied something, the original cost, by 0.95. And you've gotten 452. And to solve anything like this, it's basic algebra. You're doing the inverse. And the inverse of multiplying by 0.95 is dividing by 0.95. And of course, you get 475.789473, blah, blah, blah. Money is always to 2 decimal places. So round. And that is why the answer is £475.79. Even though this is an 8, there's a 9 next door. Right then. Make x the subject of y is equal to 3x, take away 2, worth 2 marks. Pause it. And we'll go. We've seen how to move things from one side of the equation to the other, whether you're using the balancing mode or whether you're using the inverse mode. The same is true here. Remember, y, x, t, a, whatever the variable is, they are just numbers. So you are allowed to use the same rule with these as you would with numbers. And because I can do that, I can inverse these. And you have to remember BIDMAS. The answer for this one, by the way, is D. X is equal to y plus 2 all over 3. Because you start by inversing the last thing that affects the x. And the last thing that affects the x, according to BIDMAS, is subtracting 2. So I add 2. And the next thing that the first thing that affected the x was multiplying by 3. So I'm divided by 3. And remember, you're dividing y plus 2 by 3, not dividing 2 by 3 or y by 3, but both of them. The answer to y is y plus 2, right? So make sure that your line is all over 3. Or if you're writing it differently, BIDMAS again, you need whatever's doing in the brackets to happen first. That would work as well. But as higher students, we would expect you to write it like this. This is correct, but expectation would be like this. Right, another good one that comes up quite often is prime factors. Okay, now if you have a two-parter such as this, right, they usually want you to use your answer in the first part to find something in the second part. Right then, so have a go with it, and I'm ready to rock and roll. Right then, product of 98, prime factors. So you're breaking it down into prime numbers that you can multiply together. That's what factors means. And prime numbers 2, 3, 5, 7, 11, and so forth. So you're breaking it down. So divide by prime numbers until you get nothing but primes. Okay. Now, looking at the second question here, find the lowest common multiple. It didn't ask you for it in index form. So I would leave it as this, since it didn't ask it for you, ask you for the answer in index form. I'd leave it like that because you need it to find the LCM. You need it in that way. Well, the method I use anyway, right? The method I use for this one is using Venn diagrams. So 98, we've done that in the first part. So now we're going to find the prime factors of 42, which is 7, 2, and 3. And then I use a Venn diagram. You don't need the rectangle here because all the numbers are going to be in the circles and you're going to have an intersection. Now, to find the LCM, you multiply every single number. Now, 7 appears once here, so it goes into the intersection because it appears twice here. And the other 7 would go into the circle of 98. And you're left with 3 in the right-hand circle, and 2 goes in the center because it happens here and here. And you multiply them all, 7, 7, 2, and 3 together to find the LCM. If you were finding the HCF, it would only be the numbers in the intersection. These are the types of questions you'll see, okay? Right then, this is, for the first part, this is probably the harder of the first part of here. So Perry invests 25,000 for 3 years in a savings account. The savings account pays compound interest, important word, at a rate of, now here is where it gets complicated. You have to make sure that you understand what this actually says. You are given 2.7 for the first year and 1.4% of each extra year. So basically 3 years, 2.7 for year 1, 1.4. I should put percent there, shouldn't I? For year 2 and 1.4 for year 3. So what we would expect to see for your 3 marks here is, first of all, you would need 2 multipliers, right? You're increasing, so it's going to be 1.027 once. Then you're going to be multiplying by 1.014 and again 1.014. Now this could look like this as well because you're multiplying a number by itself. Square it. Okay. But what I'm telling you here, right? This one is done. Fair play. I've built this so that it's done step by step. And you'll find this with a lot of GCSE questions that they do give them. They could have put this information for you in 1 row with no shenanigans, but they've done it in 2. There's enough room, right? It's because that they entice you to do it in steps. So instead of doing it like I did, going 25,000 multiplied by 1.027 multiplied by 1.014 squared, you can do that. It's quick. But this is enticing you to do it in steps. So first step, boom, right there. Second step, boom, right there. And it's very, very clever as well. 3 marks. You got a mark here. You got a mark here. And for that final, because you're going to get a longer number, which you are going to have to round, and you need to make sure that you're putting your units of measurements in there, because we're talking about cash, money. You need to remember pounds and pennies. But your third and final mark would be for the final answer rounded correctly. Okay. Even though I did it in one go there, it's implying that he wants you to do it in steps to show. Remember, an exam is there for you to show off that you know what you're doing. And that means that it is very pressure driven. You're very pressured at the moment. You've got so many exams going on. I'm sure you're all feeling very, very anxious. I remember the feeling well. I've been doing this for 20 years nearly, right? And I've seen students, I've seen their anxiety. I remember the anxiety. You're not alone, I promise you. The important thing here now is to try and keep yourself calm. I know it's difficult. One of the, focus on what you're doing. Don't rush it. You do have an hour and a half. You do have a minute and a mark. Okay? If you get stuck and you're seeing that time is ticking on, you're going over a minute for a 1 marker, move on, come back to it later on, right? Balance it out by how many marks the question is. This evening, I know it's after 6 o'clock now, but have an early night, right? Make sure that everything is ready before you go to bed. Make sure you have a pencil, a biro, rubber, the geometric tools, the calculator. Make sure that everything is sharpened and ready to go. Make sure that you have these things. Make sure that your bag is ready to go and by the door before you go to bed this evening, right? So that you don't rush out the door, right? Arrive to the exams with plenty of time. Don't be 5 minutes before the start of the exams about to happen, because you might be panicked. And as I said, organize your equipment beforehand. Now, I missed one bit here, which is to breathe. I know people think, I always breathe. I always do. What we mean is breathe to calm yourself, right? Sometimes as adults and people who are going through anxiety, we breathe quickly and through our mouths, and so it makes it worse. So one of the tactics of helping you go through anxiety and go through stress is to concentrate on your breathing. What you're doing is you're concentrating on something else and not the things that panic you, not the things that stress you. You're giving your brain a break. Now, the one that helped me was breathing in, holding it for 3, and breathing out for 3. Always count to 3. Okay, always count to 3. Now, the suggestion that's here is count to 4. So breathing in through the nose for 4, holding it for 4, breathing it out for 4, and holding it for 4. That didn't work for me, right? For me, it was 3. 3 in, hold, 3 out. I didn't hold that last one, but this is a tried and tested techniques for people. So please make sure that you go in, breathe in, and breathe out. Okay. And out through your mouth as well. Okay. Right then. So we've done the first part, which is to revise basic exam skills. Okay. Hopefully, just go through those little words: reciprocal, prime factors, compound interest. Understand what they mean. Okay. Right. Things that you can do in 5 minutes after we finish here. Right. Let's get to the practice, the core skills. Right. When you get to the higher topics, the topics that bug people. This one, frequency table showing the time taken for 100 people to travel to their workspace. On the grid, plot a cumulative frequency. Another phrase that you need to understand, cumulative, when you're collecting. Now, you're given graph paper. You are given a frequency table there. When you are given something like this, make sure that you're adding another column, right? There's enough space on the paper to add another column. Here, it's adding another column to your frequency. So your cumulative frequency column. So 9, 25, which is 9 plus 16. 45, which is 25 plus 20. Okay? So you're making sure that you're adding to your column. The same is true when you have estimating the mean or finding the mean from a table. Always add the column for your midpoint. Okay? Now, with cumulative frequency, you've got 9 by the end of your grouping. So your mark should be at the end of the group. So time, it's going to be 9, so it's going to be around here somewhere. Boom. You're going to mark there because it's the end of the group. That's where you've got 9 within that group. Okay, there it is. Now, don't draw with a ruler. This should look like a curve, a nice smooth graph. And the same is true for a quadratic graph or a graph. Okay, they need to be smooth. Don't use rulers. Use freehand. Now you're thinking, oh, it's going to look a bit iffy, but it's better than looking a bit clunky. This one looks a bit clunky because it's computerized and we haven't been quite able to curve it. What we were looking for here is a nice, smooth looking graph. All right. That one's a bit iffy, but it's all right. Okay, nice, smooth looking graph. And when you find the second part is use the graph to find an estimate, because it's an estimate, because you can't tell what these 9 pieces of data are. They're just between 20 and 30. So it is an estimation. Remember, median is the middle, right? So you're finding the position of your middle. Now you've got 100 pieces of data. Your 100 pieces of data means that it's between the 50th and the 51st piece of data, right? Which is about here. Then you're projecting onto the cumulative frequency graph, and then you're projecting downwards. So you've got there, it gives us 52. But in the marking scheme, it will give you a little bit of leeway. Some people, because you're not drawing this with a ruler, you're making sure that it's curved nicely with your freehand. There is going to be a slight variation. That's why it's estimating as well. So every time you hear the word estimate in a question, there is going to be a range of answers. All you need is one number within that range. Okay, one number within that range. Right then, 2-mark question. But again, even though this is a 2-mark question, see how the question has been laid out. Okay, it's laid out in nearly bullet points. It doesn't give you these bullet points that you get, but it has. There's enough room to write the rest of the sentence here, 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 but it doesn't. It goes on to the next question. It goes on to the next line, sorry. Okay? And that's because they want you to see the information clearly, right? So in a gym, there are 12 exercise classes on a Monday, 13 classes on a Tuesday, 7 classes on a Thursday. David is going to attend either. Not my cup of tea, but fair play to him, right? A class on Monday and a class on Thursday. Again, bullet points. How many classes are on a Monday? 12. How many classes are on a Thursday? 7. We're talking about, okay, there you go. Classes Tuesday, classes on Thursday, class Monday, Tuesday, Thursday, right? Show that there are 1,267 ways for David to pick which exercise classes he attends. So as it says in the title there, this is a product rule of counting. You're trying to show how many different variations David could choose. How you do that, of course, is by multiplying. It says product rule for counting. Product is the end result when you're multiplying. So, and again, look at this. 12 times 7, Monday and Thursday. You're taking it in that. Tuesday and Thursday, 13 times 7. Monday, Tuesday, Thursday, 12 times 7. 12 times 13 times 7. So for me, you're looking for these numbers. This will be your first mark that you've worked correctly with the product rule for counting. Okay. The second mark is, of course, for you to be adding them together. And this is vital. Even though you've got the right answer in there already in the question, it tells you to show. You need proof. Okay? Proof. I'm going to put a P with a dot there to show proof. Evidence, people, evidence. Always give us evidence to prove your understanding, whether it asks it for or not. It is your time to shine, people. Remember that. Bit of algebra now, right? Oh, the hated algebra, my friend. Remember, algebra, these variables, these letters that people get confused with, they're just numbers. We don't know what they are yet. Now, use algebra to solve simultaneous equations. Simultaneous means that they happen at the same time. There are different methods, of course. My preferred method is getting rid of one of the variables, because I don't like dealing with two variables. Too much information, it just confuses me. So my preferred method is to get rid of one. Now, the problem is I can't do that because they have different coefficients. How do I solve that? I make sure that they have the same coefficient. So to explain, make sure that you're labeling your simultaneous equations. I've labeled the top one with equation 1, made a circle, equation 2 with a circle, so that you don't get confused that you're taking 1 away from 2. By putting a circle in there, you're showing this is equation 1, this is equation 2. And of course, show you're working out, right? So what I've done here is I've made sure that the coefficients of y are the same. So I've multiplied 1 with 3, and I've multiplied equation 2 with 2. So what I have here is y has a coefficient of 6 here, and it has a coefficient of -6 there. That's important to remember, okay? Some of the mistakes that happen here is, oh, how do you get rid of 6? Oh, you take 6 away from 6. Not in this instance, because that is a -6. How do you get rid of a negative, people? You add. You put positivity in there. So to get rid of a negative, you add. To get rid of a positive, you subtract. And so by adding equation 3 and 4 together, I get an answer of 26x equals to 52. And of course, that's just a normal equation, isn't it? Right? We do the inverse, right? Or balance, whichever method you prefer. So 26x divided by 26 equals to 52 divided by 26. And it gives you an answer of x, because 26 and 26 turn into a 1. Anything multiplied by 1 is itself. 52 divided by 26, 2. Don't stop there, people. Don't stop till you get enough, as Michael Jackson used to say, right? Once you have found x, you need to find y. Because that's the whole point. Solve the simultaneous equation. You need both variables. Because you found x, use it, right? And do input your value of x into one of these, into the original equations, not to any of the ones that you found since, the originals, please. Okay? You get y is equal to -7, and before you finish, it's not part of the marking scheme, this one, right? It doesn't ask you to check. It just asks you to solve. You've done it here. Clearly, x is equal to 2. Y is equal to -7. But for your own sake, check. Always check. And how do you check? Well, input the values of x and y that you have found into the other equation. So I've used the first equation here to find y. So what I'm going to do with the next one is input x and y into the second equation. And if it works like it does here, you know you've got both the same answers. Right then, chiefs and cherubs. I'm going to have to squeeze through this one a little bit. I would like to go through this one with you. I skipped a little bit there, because these are the types of questions that people struggle with. The sine rule here, okay? Here is a triangle ABC. Work out the length of AC. Give your answer correct to 1 decimal place. What you see here, triangle, 2 angles, 1 length. Now, I don't I see that it's not a right angle triangle. It's obviously not a right angle triangle. It's not asking me to prove that it's a right angle triangle. And that angle ABC is definitely not right angle. Neither is BAC, neither is ACB. Okay, so I know it has to be either the sine rule or the cosine rule. I've got two angles and a side. Personally, I'm looking at the sine rule here. Write the sine rule down and identify each part that you need. Okay, so this angle here is opposite this side here. So we've got that. So you've got 12 over sine 55. Now, I need to know this angle here to find B, which is line AC. I don't need to know this side, but I do know a rule that would help me find that angle. The simple angles in a triangle rule. Okay, so B over sine B is equal to A over sine A. Those are the two that you need. So AC over sine B is 12 over sine 55. Now, what you need to do is inverse sine B. Do not inverse the trig. Inverse the whole lot. Right? To solve this, you need to inverse the whole lot. So it's not sine to the negative 1 or arc sine, right? It is multiplying by sine B. So you have found the angle, which is 105, which makes sense. It looks like an obtuse angle. So AC is equal to 12 over sine 55 multiplied by sine 105. Okay. Make sure your calculator is in degrees mode, not in radians, degrees. Do it. Do it tonight. Pause. Do it now. Right then, we've come to the end of the second part to practice core skills and cover misconceptions. I hope I've done that as much as I can. Right, let's get to the big ones, right? Let's get to the ones that we have here. So to analyze multi-mark questions and to maximize how many marks you get. This is a big one, the 4-marker. We've seen a 4-marker before, but these tend to get a bit harder now, okay? So the diagram shows an empty tank shaped like a cylinder. Cylinder, boom. Think of everything that you can about cylinder. Think of all the rules. Cylinder is a circular shape, so anything you can think of with a circle. The cylinder has a diameter of 40 centimeters. Diameter, good one. It has a height of 1.87. That, to me, either implies surface area or volume. Water flows into a tank at a rate of 0.34 litres per minute. Going into the tank has to be volume. Calculate the number of minutes it will take to completely fill the tank. Give your answer correct to the nearest minute. Okay? So here you're looking for 4 steps. 4 easy steps that will take you to the answer of how many minutes. And at the end, give your answer correct to the nearest minute. Say it will take this amount of minutes. Okay? Write that down. Write a sentence down. Now, a tip that I can give you here. Cylinder, diameter 40 and height of 1.8. For me, it implies that you're trying to find the volume first. Okay? So, write the formula, input the data, input the information into the formula, and leave your answer in terms of pi. Why? Oh, why would I do that? If you get an answer, if you put 72,000 pi into your calculator now, you are going to get a number that's very long, loads of decimal places. What you would do really naturally here is you would round that answer. Every time you round an answer that you're going to use in the next step, you lose accuracy. So never round. The most accurate answer that you can give here is 72,000 pi. That's worth 1 mark. First step. Look, boom. Water flows into the tank, right? So this is where you have to know your knowings. You have to know what everything means. 1 litre is equal to 1,000 centimetres cubed. Make sure you know these little things tonight. Go through them. Conversion rates of area from metres to centimetres. Conversion rates of litres to centimetres cubed. Little things that you can do quickly tonight. And tomorrow morning, write them down this evening. On a piece of paper, take them with you, put them in the bin or in your bag before you go in. Bob's your uncle, Mary's your auntie. You've done something. So convert the volume then into litres. And again, we've left it Right, we've left it in terms of pi for accuracy's sake. Second step, you've pretty much used that bit again. Now, you know the time taken. So we're using this piece of information now, right? 0.34. So time taken would be 72 pi divided by 0.34, right? You're trying to find out how many 0.34s will fit in. So every minute you're filling in that much, okay? That gives us 665.27844 minutes, okay? Because we're dealing in per minute, it has to be, right? Round that to the nearest, what do you call it, is 665 minutes. Now, because some people round, don't use pi. I always advise to use pi right until the end. Don't use pi at the end. No. Always make sure that you've got there, okay? 664, not take away, sorry, it's in between. So we're looking for an answer of between 664 and 668. You do have a little bit of leeway there, all right? Right. Again, a 3-marker, okay? Density. A liquid A and liquid B are mixed to make liquid C. Liquid A has a density of 7 kilos per meters cubed. Liquid A has a mass of 1,400 kilograms. Liquid B has a density of 200 kilograms per meters cubed, and liquid B has a volume of 30 meters cubed. Work out the density of liquid C. So you're mixing them together, you're putting them together to get liquid C. So you need to remind yourself, and it's all about density. There's a formula for density. Poof, there it is. You have to remember this. Right, these don't come easy, and density I don't think comes in the front of the page. All right, so density is mass over volume. Not difficult. Some people see it like this: density, mass, volume. Now, because you're dealing in density of A and density of B, combining them gives you the density of C. Right? Density of C is the mass of C or the volume of C. So you need to know what the mass is going to be for the combined A and B, and you need to know what the volume is going to be for the combined of A and B. So the mass of A plus the mass of B all over the volume of A, volume of B. Now, here is where you need to use these details. Again, it's happened earlier on. We put the formula down, then we substitute the values in there, right? Make sure that you're doing this step by step. Remember, it's your time to shine, people. Showing off, showing your understanding. Right, so we've inputted the data, 1,400 plus the mass of B. Do I have the mass of B? No, I don't. All right, I do have the density of B, so I can figure out what the mass is by using the density formula. So 280 is equal to mass of B all over 30. Multiplied that by 30. I know I've got 8,400, and that's worth 1 mark. We haven't even arrived at the marks here, but it's important to do. Just for your own chain of thought, really. Okay? You get there quicker if you write things down methodically. So I can input that. I don't have the volume of B. I don't have the volume of A, but I do have its density and mass. And of course, that means I can figure it out from this formula here. I've written it down. Easy peasy, squeezing lemons, that is. We find out that the volume of A is 20. Slap that in as well. So now we know that the mass of C is 1,400 plus 8,400 divided by 20 plus 30. There's your other mark. And the third and final mark, of course, is the density of liquid C. And that would give us 196 kilograms per meters cubed. Now, make sure that you're using the correct units of measurement. Density is a compound measure, so it needs a compound unit. Because it's measured in kilos and meters cubed, the combination has to be kilograms per meters cubed. Right then, where are we? Bit of vectors. Not Victor, not tractor. We're talking about vectors. Vectors, remember, have magnitude and direction. Okay, the direction is important. You've got OT, this one here, and they've labelled it as little a, right? You can put a line on the top because we bolded them. You can put a little line on the top, right? If you go from T to O, it is not A because you're going in a different direction. Remember that, okay? So from R to T is a little b, okay? Now they've combined this with ratio. So M is the midpoint ORT such that OM to MR is 2 to 3. Now they've marked it here. If they haven't marked it, you do it. It doesn't have to be accurate. It's just a sketch, okay? Express MT in terms of A and B. Now you want to get from M to D this way. You can mark the path that you want to take, okay? It has to be 2 marks. M to R plus R to T. Now, as it happens, we know what R to T is already. What we've got to find is what M to R is. And that is a combination of getting from O to T to R to M. But actually, because we're talking about part of OR, go from O to T to R, and because you're talking about ratio, you can work it from there. And of course, because you're going in the opposite direction, you're going that way, it's going to be minus, isn't it? So O to R is that path there. So it's A, take away B. It's take away B because you're going in the opposite direction. Okay, that's O to R. Now, M to R has to go O to R 3/5 of the way. So it's 3/5 of A take away B. Right? Now, M to T would have to be M to R plus R to T, which is 3/5 of A take away B plus B. Now, to get your final mark here, you need to simplify this, okay? So it's basically 3/5 A take away 3/5 B plus B. Now you've got a negative 3/5 B, add B here. Very careful on that one, people. Very careful. So it becomes 3/5 A plus 2/5 B. That is the path that you need to take right there. Right then, I think I've got just about enough time before our question and answer section to do this question. So y is equal to 1/4 x to the cube. X 8.4 correct to 3 significant. We've seen that before. We saw it earlier on, didn't we? Correct to 3 significant figures. That means that that number has been rounded already. Consider bounds. It says it right there in the question as well, doesn't it? Work out the value of y to suitable degree of accuracy. Give you reason for your answer. Again, reason. Show your understanding. Your time to shine, people. Okay? So what you do here is you make sure you think of the bounds that you could take, right? So x is rounded. So lower bound for x and the upper bound for x. Think of both of them. That means your upper bound for y, well, you're using your upper bound of x, and your lower bound for y, you're using your lower bound of x. Right, there's a wrong way round to what I did there, but there we go. 8.3 lower bound for y, you're using the lower bound for x. 8.45 upper bound for x. Okay, there's your second mark. So recognizing the bound, first mark. Putting them into the calculation, second mark. Getting an answer, right? Work out the value of y to a suitable degree of accuracy. So your fourth mark, basically, we're looking for a certain degree of accuracy here. 150, right? Since both the upper and lower bound to this to 2 significant figures. So when you're rounding, you have to think about it. Okay, what makes sense here? So if I round this to 2 significant figures, they've done it to 3 here, but you're looking for one number. So if you want it to one number, it has to be to 2 significant figures without going over the top here, isn't it? Okay. Right then, we've come to the end of what we've prepared for you. Now, what we want to do with you now is do a bit of question and answer with you. And I hope you've kept Alex busy. He hasn't been communicating with me to tell me, time, you're going over your time too much. So I'm hoping that you've been keeping him busy for me. Thank you for that. Right then, let's have a look at what you've been asking for. Right then, estimating the mean from frequency tables. Always remember, mean. It is the meanest number of them all, people. I know. Why is it the meanest number of them all? Because it takes more work. So here's an example of estimating the mean. Now, I discussed this earlier on when we were doing cumulative frequency. Okay. You've got a table with 2 columns in it. When you've got something like this, you need to add columns. Now, this is not discrete data, it's continuous data. How do I know this? The inequality marks. Okay, we're taking into consideration every number up to 10, but not including 10, between 10 and up to 20, but not including 20, and so on and so forth. Okay, that means that these 8 could be any number between 0 and 9.999999999. We don't know which ones. That means that you have to find a number that is reasonable to use from this group, and the best number to use is the midpoint. How do you find the midpoint? Well, the midpoint is always your top number, add your bottom number, divide by 2. So 0 plus 10, 10, midpoint is 5. 10 plus 20, 30, halfway, 15. 20 and 30, you'll see that it comes to this, really. You'll see a pattern emerging with most of these, unless they're being sneaky and they change the range of each group. Sometimes they do that, by the way, the sneaky devils, right? Sneaky devils. So 45, okay? So we've added another column there, add another one, right? You could call this one, by the way, X, and you can call this one F. So this column is F of X. What that means is you're multiplying your frequency by your midpoint. I put them the wrong way around there, sorry. I put midpoint times frequency, but it doesn't matter with multiplication, does it? Right, so frequency, 10, 15. 7 times 25. 2 times 35. And 3 times 45. Okay. And of course, this is a calculator paper, right? Boom, Bob's your Uncle, Mary's your auntie. You can get the answer, right? You can draw an extra column there, or you can put it in this column. It's up to you. So 5 times 8 is 40. 150. 7 times 25. Oh, I'm going to look like a right plonker if I get these wrong, aren't I? I'm not using my calculator, I'm using my head. It's been a long day, people. It's been a long day. 70 and 90, 135. Now, that's only part of the question. It's asking you to estimate the mean. Like, what you've done there is you have found the amount of snow in each group. Okay, so the table shows the amount of snow in centimeters that fell each day for 30 days. Okay, so the data, your information is in the first column. Every time your information is in the first column. So you mean someone corrected me there. I look like a right Wally now, don't I? It's the 135, the last one. Nice. Right. Where was I? Oh, yeah. The information is always in the first column. So your mean, your mode, your median are always going to be between your bottom number, which is 0, and your top number, which is 50 in this example. So your mean has to be somewhere in there. I am guessing that it has to be here somewhere between 20 and 10. That's what I'm guessing, because the frequency is higher there. Something to do later on. But you need to add these now. So 0, 0, 5, 5, 10. 4 and 5, 9, 16, 23, 26. Then 1, 2, 3, 4, 5. You've got 560 centimeters of snow in the 30 days. Now, because we want to find the mean is add them all up. All right. So it's your total of f of x divided by the total of your frequency. Some of you may have not seen that formula before. Well, you probably add them all up and divide by how many you've got sometimes. But it's the same thing, okay? So 560, 570, corrected again. Should be using a calculator, shouldn't I? Right? 570 divided by 30. That's why you've got calculators for this one. I'm doing this in my head. And it's close to 600, right? It's close to 600, isn't it? It's 30 away from 600, so I'm guessing that this is 19. And you know what? I'm not far off, am I? The answer is in that group between 10 and 20. Here, make sure that you're using the space that you have on the paper to create more columns. I've done it very, very quickly by hand here, right? To show you how you can do it quickly. Use rulers, use pencils, okay? Use it. Right then. Next. What would you like from me? Sectors. Oh, sectors. Sectors and circles, circles and sectors. Right then, find the sector area, find the arc length, find the perimeter. I'm going to have my calculator here because with these, unless it is stated in your question, use pi. Not the steak and kidney kind, but the mathematical kind that Welshman found or used for the first time. Professor William Jones from Amlwch, where I'm from. Not quite there. Claim to fame there, people. Claim to fame. Good mathematicians on Anglesey. Anyway, sector area. What we see is that a sector is part of a circle. How much of a part of a circle? Well, the only piece of information there is if you've got a radius of 5 and an angle. Oh, that's interesting. An angle. An angle of a circle. Well, there are 360 degrees in a circle, so that's 80 degrees out of the 360. So what you know is that the area of a circle is a pi r squared, and what we've got here is 80 out of 360, and you can simplify that. 8 out of 36, which is 4 out of, I'm going to go with 18, which is 2 out of 9. I'm right. I'm going to be corrected now by Alex. He's correcting me. He's doing it with his calculator quickly. So you've got 2/9 of a full circle there. So the area or the sector, I'm going to put it SA here, sector of the area, right, is 2/9 of pi 5 squared. On your calculator, this is why it's very, very important for you to know which button is which on your calculator, because you've got a fraction and pi here, right? So I always put pi first. It doesn't matter which way around you put them. It doesn't, because it's multiplication. It doesn't matter. Multiplied by, I know that 5 squared is 25, but I'm going to put 25 in there, right? I'm going to put 5 squared in there for the sake of argument. And then I'm going to multiply it. And I've got a button for the fraction right here, if you can see that. 2/9. And it gives me 50 over 9 pi. Press the SD button, I get 17.45, rounded to 2 decimal places. I would round centimeters to either 1 or 2 decimal places, okay? Meters to 2 decimal places, definitely. Millimeters to 1 decimal place. And since it's area, we need centimeters squared. Arc length is the same, all right? Arc length is, well, we've got 2/9 of 2 pi r, or diameter r, okay? Diameter pi, sorry. Depends on which formula you're used to. 2 times 2 is 4. So it's 4/9 pi r. Pi is 5, so 5 times the radius is 5 times, and the fraction 4/9. Boom. What you've got there is 20/9 pi, or 6. And since this is centimeters, 98 centimeters. And you need to make sure that you're saying to 2 decimal places. Okay. Perimeter, different. Arc length, all you've done is found the curved edge. It's part of the circumference. You're not taking into consideration the straight lines. So to find the perimeter, you would need to add these 2 sides as well. So the perimeter would be 6.98, which is the arc length, plus 5 plus 5, which brings us to 16.98 centimeters. Right then, I've been informed that I'm getting very, very, very close to the end of the time that we do have together here now, people. I hope that my tricks and tips have been useful to you, right? Now, I know some of you are very anxious, some of you are very nervous. You don't know what to expect from the paper tomorrow. After tomorrow, if there is a topic that's not in the paper tomorrow, it will definitely be in paper 3. So you've got a better idea. But make sure that you're going through those breathing exercises. Make sure that you're getting everything ready. Make sure that you're writing a few words down, like prime, factors, a reciprocal we've seen today, cumulative frequency. Make sure that you're writing these down tonight, bringing them on paper with you tomorrow morning, right? Going through them on the bus or in the taxi or on the walk to the way to school. Make sure that you're looking up, right? Don't walk into the middle of the road looking at your maths test. No, don't do that, please. Breathe. Have a good night's sleep. Have a good breakfast. And when you get there, make sure that it's about a minute a mark, okay? Minute a mark. Right? Make sure 80 minutes, 80 marks, and you've got 10 minutes at the end to go through it. If you can find time, the 1 markers, right? If you can find the time of the 1 markers, yeah, keep it, okay? Right. Thank you ever so much for joining us this evening. It has been an absolute pleasure. Okay. I do hope that you're feeling more confident walking away from this. And if you're not, watch it again. Right. If you found me boring, it's all right. It'll get you to sleep this evening, won't it? If you watch it again, put it on your phone, headphones in. You'll be asleep in no time, I'm sure. Make sure that you check your timetable this evening to make sure that you are in your school with enough time. Okay. I cannot guarantee it that it'll be 9 o'clock. It usually is, but that's no guarantee. Check your times now. And we're here next week as well. All right, don't worry, we're here next week as well. Same time, same place. Look at your timetable there. Your feedback helps us to improve, so please take a moment to complete the pinned form in the chat. Don't forget to hit subscribe and turn on your notifications. Here's where people point to directions I haven't got a clue where it's going to be. So huge thanks to you once again for being part of this evening's revision. Remember, you got this. You can do it, people. You can do it. Best of luck to you in all your exams. I'm rooting for you. I really am. Never met you. I'm still rooting for you. Keep focused, stay motivated, and believe in what you've learned. Okay? We'll see you next time, and I will see you next time, which is next week. Okay? So thank you.